Hello everyone, welcome back. In our previous lectures, we were discussing about factors, multiples. We discussed about prime numbers, prime factors, and I taught you how to calculate square root of a number by using the long division method. Today, we are going to calculate finding the HCF and LCM. Now, what is HCF and what is LCM? LCM is least common multiple and HCF is highest common factor. Now, you must be thinking, okay, what is she saying and what is she trying to say? So we've already discussed about factors, right? Now, what if I'm giving you two numbers and I'm asking you to calculate the common factors? Or if I'm giving you two numbers and I'm asking you to calculate the common multiples? How are you going to do it? Now, when I discuss about or when I talk about least common multiple, to calculate the least common multiple for two numbers, I'm going to write the multiples of all those numbers and I'm going to see the common multiples. And then after seeing the common multiples, I'm going to see which of them are the least. So that will simply going to give me the least common multiple. The definition is quite easy and must be clear. Let us see an example over here. For example, I'm giving the common multiples of 3 and 4. So I can write all the multiples of 3. Multiples of 3 will be the table of 3. That is 3, 6, 9, 12, 15, 18, then 21, 24 and so on. And if I write the multiples of 4, then I have 4, 8, 12 and 16 and 20 and 24 and 28, 32 and so on, right? Now let us see which are the common multiples. Clearly I can see that 12 is a multiple of both, so I'm going to highlight 12. I'm so sorry. And then I can see that 24 is a multiple of both, so I can highlight 24. After this I can see, now I can observe a pattern that all the multiples of 3 and 4 are actually the multiples of 12. So after 12 I have 24, after 24 I'll have 36, after 36 I'll have 48, after 48 I'll have 60, after 60 I'll have 72, and these will be the common multiples. Now which of these is the least? These are the multiples, that is 12, 24 and 36, and the least number is 12. So easily I got my lowest common multiple is 12, right? Quite an easy concept. What about if I talk about highest common factor? Now the way we calculated multiples, similarly we can calculate factors of any two given numbers. For example, over here if I have 8 and 12. So I have to calculate the common factors. Now to calculate the common factors, first of all I have to see what are all those tables where 8 occurs and what are all those tables where 12 occurs. So if I have to write the factors of 8 will be 1, 2, 4 and 8. And the factors of 12 will be 1, 2, 3, 12 occurs in the table of 4 and 6 and 12 as well, right? Now what are the common factors? Clearly 2 is a common factor, 1 obviously and 4 obviously. So now which of them is the highest? Highest is 4. So my HCF for 8 and 12 is 4. That was quite an easy task. Now what is the use of studying HCF and what is the use of studying LCM? What is it? What are we going to do with it? Now the fact is that whenever you have say large numbers, suppose I'm giving you a 6-digit or a 5-digit number, are you going to calculate all the factors? Because that will be a really long list then. And then are you going to calculate which of them is the highest? Obviously not. Then we're not that stupid. So there is a technique to calculate HCF. There is a technique to calculate the LCM as well. This was quite easy because you were just using the definition to find out the HCF and the LCM of two small numbers. But what if I'm asking about say a 5-digit or a 6-digit number, right? Then you'll be confused. But what's the use of studying HCF or LCM? In our previous lecture, we discussed about, a question. We discussed a question that was, just let me open up that question for you. Over here, we discussed this question about a bell ringing after 6 seconds and another bell ringing after 5 seconds. And now obviously all of you go to school and we have our schedules, the classes for say year 8, 9 and 10, a bell is gonna ring in a different tone, and for say year 1 and 4 and 5, the bell is gonna ring in a different tone. But it is supposed to ring in such a way, irrespective of the number of lectures, it is gonna ring in such a way that everybody has their school maximum say till 5 o'clock. So you know, you obviously need vacation after that. You need a break from all the studies that you're doing. So how do we actually do that? So this is the use of HCF or LCM in common life. So coming back to our concept, how are we going to calculate HCF and LCM each time when I'm given a large number? Now HCF is defined technically as product of smallest power of each common prime factor, and LCM is defined as product of greatest power of each prime factor in the numbers. Now you must be thinking, okay, what did she just say, and whoa, what did she read? So basically, let me explain it to you with the help of examples. For example, now let us pick the example that we just took. For example, we took 4 and 8, or we took, I guess, in our previous slide we took an example of 8 and 12 actually. So let us take the same example. I'm gonna explain it to you with the help of this example, and then I'm gonna take large numbers and find their HCF. Alright, so 8 and 12. Now I can write the prime factorization of 8, and I can also write the prime factorization of 12. We have discussed in our previous 2 lectures already. So the prime factorization of 8 is simply 2 cube, and 12 can be written as 4 into 3, that is 2 square into 3. Now in over here, 2 I can see is occurring in both of these. So when I talk about product of smallest power of common prime factors, now what are the common prime factors in both their factorization? I can clearly see 2 is common, right? So whenever I'm writing the HCF, I'm directly going to write it 2, and then I have to take the product of smallest power. So over here, when I'm writing in 8, I have 2 cube, and when I'm writing the prime factorization of 12, I have 2 square. So which has a smaller power? Is 2 square small or is 2 cube small? Clearly 2 square is small. So I'm simply going to write 2 square over here, and that's my HCF, that was 4. Let us see back there. Obviously we calculated 4 over here similarly, and in a similar way I got 4 over here. Now what is the use of this, and why are we not using that, the one that we did previously? I told you, when we talk about large numbers like 5-digit numbers or 6-digit numbers, so you're not always going to write the factors. You may skip some factors. You're not going to always write them and then see which of them are common and then see which of them have the largest. So the simplest technique is calculate the prime factorization of all the numbers that are given, and then you have to see which of them are common factors, and you can judge the powers accordingly. Similarly, if I talk about LCM, let us go back. Our example for LCM was 3 and 4. So over here again I'm going to take 3 and 4. So when I'm talking about calculating the prime factors or prime multiples of 3 and 4, product of greatest power of each prime factor. Now 3 can be simply written as 3 into 1, and 4 can be written as 4 can be written as 2 square, right? So I have to take each factor. Now notice, while calculating HCF, I took only the common factors. While calculating LCM, I have written over here each prime factor. So LCM is equal to, now first of all taking the prime factors from the factorization of 3. So that's just 3. And from here I have the prime factorization 2 square. So that means 2 square. So simply 3 into 2 square, that is 3 into 4, that is 12. And we got our answer as 12. But how can we use it in different techniques? For example, look at these 2 numbers over here. I have to calculate the LCM and HCF. So calculating the LCM and HCF of 26. First I did their prime factorization. That's the general technique. So I wrote 26 as 2 into 13, and then I wrote 91 as 7 into 13. Right? Now while calculating the HCF, I told you HCF is the product of product of smallest power of common factors. Now what are the common factors of 26 and 91? 13 is common, right? And the least power of 13 is 13 to the power 1. So clearly my HCF for 26 and 91 is 13. Similarly, I'm going to calculate the LCM. What will be the least common multiple? Now again, I have to take all the factors, all prime factors together. So, but I do not have to repeat my prime factors. So for 26, I have 2 and 13. And while writing 91, now already I have written 13. So I'm not going to write it again. The powers are same over here. So I'm simply going to write 7. If I had 13 square, then I would be taking obviously the greatest power, that would be 13 square. But over here I have 13 to the power 1, so I do not have to actually rewrite it. So my answer will be simply 2 into 7 into 13. 2 into 7 is 14 and 14 into 13 can be calculated as 182. So my answer comes out to be 182. HCF is 13 and LCM is 182. Now let us look at another example. Again, 510 and 92. Now again, I'm not going to write all the factors or all the multiples of 510 and 92 to calculate their LCM and HCF. This is my simplest technique that I'm using. I simply have to prime factorize them. So I have written their prime factorization as 2 into 3 into 5 into 17 and 92 as 2 into 2 into 23. Now to calculate the HCF. Again, I'm going to see the common factors. What are the common factors? I can only see 2 over here. 2 is my only common factor, so I'm going to write 2. And what power of 2? I have to write the smallest power of 2. Now over here I have 2 to the power 1 in 510, and in the prime factorization of this 92 I have 2 square. Now what does that mean? What should I write? 2 to the power 1 or 2 square? Clearly 2 to the power 1 is smaller, so I'm going to write the smaller power. So HCF of these two numbers is simply 2. That's the highest common factor. Then calculating the LCM. Let us see what LCM will be. I have to write all those prime factors. I just don't have to make any repetitions, but I have to write all the prime factors, and I have to write greatest power of prime factors. In HCF, I'm always writing smallest power, and in my LCM, I'm writing greatest power. So I have the prime factors as 2, 3, 5, 17. Now over here I have 2 square again, right? So I had to write the greatest power. So I'm not going to write 2 square again totally. So over here when I have written 2, I can simply replace this 2 by 2 square because I had to write the greatest power, and into 23. So this is going to give my answer. So this will become 2 square is 4, 4 into 3 is 12, then into 5 will become 60, into 17 will become 1020, and into 23 will give me the answer as 23,460. That's my answer to this question, right? So I hope the concept of LCM and HCF is clear, and we can calculate a few more numbers. Now let us try to do it on our own. We are gonna prime factorize it on your own. Alright, I had done it previously for you. Now you have to do it yourself. Try this one. Again, I'm going to explain the technique of prime factorization in case you have any confusion. So what's the technique? Now whenever I'm writing 42 over here, I have to find the least factor of it. Starting with 2. 42 divided by 2, 21. Now it's not a multiple, or 21 is not a multiple of 2. So next will be 3. So I'm going to write 21 divided by 3, that is 7, and then 7 over here. So 42 can be written as simply 2 into 3 into 7. Now calculating the prime factorization of 63. 63 is not even, so we're not going to write 2 over here, starting with 3. 63 divided by 3 is simply 21, right? 1 into 3, 3, 2 into 3, 6, right? Then again 3 into 7 is 21, and then 7 and 1. So 63 can be written as 3 square into 7. Now over here I had all powers as 1, and over here I have 3 square into 7 to the power 1. Now calculating the HCF. Again, I have to see the common factors. What are the common factors? Only 3 is common. So I'm going to write 3. And the smallest power of 3. One side I have 3 to the power 1 and the other side I have 3 square. So the common or the least power of the prime is 1. So I'm simply going to write 3 to the power 1. Calculating LCM now. What will be the LCM? So LCM will be calculated as, I have to write all the factors. So 2 into 3 into 7. But over here I have 3 square and one side I have 3 to the power 1. And while writing the LCM, I always write the greatest power. So this will become 2 into 3 square into 7. So 3 square is 9. 9 into 2 is 18 and I have to solve for 18 into 7. So 18 into 7 will give me about 126. So my answer is 126. It was that easy, alright? Let us find the HCF of 48 and 120. Okay, in our previous question we just had to find the LCM, but we calculated both. So you can see how this technique is useful in calculating both LCM as well as HCF. Alright. Similarly, I can find HCF of 48 and 120. So over here, although I'm just asked about the HCF, but we can, if we are following a technique, we can use the same technique to find LCM as well as the HCF. Again, I'm going to do the prime factorization first. I'm doing it over here on your screen, but I expect you to do it on your own. In case you have any confusion, then you can look at over here on the screen. But try to do it on your own. So I'm doing it silently so that you can do it simultaneously on your paper. I hope you have done the prime factorization of 48. I'm done with 48. Now I'm doing it for 120. So I'm done with my prime factorization. In case you're taking more time, you can simply pause the video and try to do it on your own and try to attain this answer on your own. Okay, so I'm continuing. Now to find the HCF, I have to look at the common multiples, the common prime factors. What are the factors over here? I think 2 is common and 3 is common. And so I'm going to write 2 into 3. And what is the least power? One side I have 2 to the power 4 and other side I have 2 to the power 3. So least is 2 to the power 3. So I'm simply going to write 2 to the power 3. And over here with 3 we have both powers as 1. So 2 to the power 3 is 8 and 8 into 3 is 24. So that's my HCF. Try to find the LCM. What will be the LCM? I have to write all the prime factors, that is 2 into 3 into 5. These are my prime factors. Now don't get confused. I'm not writing all the factors of 48, then I'm not writing all the factors of 120. I'm writing simply the factors together, right? And then I'm seeing what power should I put. So over here, what is the greatest power of 2? One side I have 2 to the power 4 and other side I have 2 to the power 3. So I'm simply going to write 2 to the power 4. And then 3 to the power 1, because both ways we have 3 to the power 1 and 5 to the power 1. So over here I'm getting 2 to the power 4 is 16 and 16 into, then I have to do 3 into 5 is 15. So 16 into 15, that's simply going to give me the answer as 240. I hope you are getting this correct. If not, just simply pause this video and try to do it on your own. Now, talking about our next concept, negative numbers. I hope you've already studied it in your previous classes. What are natural numbers or whole numbers? If not, I'm just going to revise it, give you a quick recap. Our natural numbers are all those numbers which we can count. Like, you know, starting from 1, 2, 3, 4 and so on. Suppose you have a plate full of, say, chocolates. and you want to count how many chocolates are you given. So you're starting with either 1, 2, 3, something that you can count. If there was no chocolate, then you're not going to count it at all. Obviously, who's going to count an empty plate? So natural numbers are starting from 1, 2, 3 and so on. Then larger than natural numbers, I have concept of whole numbers, representing it by W. Now in whole numbers, I'm simply going to write a 0 along with it. Not all the natural numbers, and along with that I get included with 0. Then after whole number, we have the concept of integers, which is usually denoted by Z or capital I. Now what are integers? Whole numbers were starting from 0, 1, 2, 3, 4, 5 and so on, right? Now integers, I include my negative numbers as well. Now what do we mean by negative numbers? Numbers which are lesser than 0. For example, whenever I draw my number line, I'm drawing my number line over here. On the right side of 0, I have 1, 2, 3 and so on. But what happens to the left side of 0? On my left side of 0, I have negative 1, negative 2, negative 3 and so on the left side as well. So my counting from 0 goes both ways, to the right as well as to the left. Alright. So now when I'm talking about a negative sign, so negative number has a minus sign attached with it. So I'm just underlining the key facts over here. It has a minus negative sign attached to it. And whenever we are adding or subtracting or multiplying or dividing by particular negative numbers, then there are certain rules that need to be followed. Now, where do we actually use the concept of negative numbers in real life? Before I explain you the rules, I just need to, you to connect it with real life situations. Where is the concept of negative numbers followed? Now, for example, you have 10 rupees in total. Or you can say, let me take a higher amount, or let me do it I'm talking about, say, a multinational company, and a multinational company is earning, say, millions and millions of pounds. But suddenly they are suffering losses now. Earlier they were gaining profits that were millions and millions. Now they started getting losses. Now they lost all the amount. So what is that amount loss? That is just represented as the negative part of the company, because now they are under losses. Now they are under debts, right? So that's the concept, that's the place where we can actually connect negative numbers to. If you have, say, 20 pounds and I ask you to give me 30 pounds. So you're going to take it from your friend, or you're going to ask your mom to give it, but you're going to pay me 30 pounds because I need it and we are friends, right? And then what's left with you? Actually nothing, because the 20 pounds that you had, you gave them to me. And along with that, now you have to repay to your mom. So you are under a debt of 10 pounds, right? So that minus 10 or negative 10 is a debt on you, alright? So that's the concept of negative numbers. Now, what did we just do? When I took 30 pounds from you, you are left with negative 10. That means you have to you have to pay a debt of 10 pounds. So what are we adding and what are we subtracting? Now remember that whenever you are adding two positive numbers, then the result is always positive. And when you are subtracting something from positive numbers, say 5 minus 3 or 2 minus 1, that is when the number that you are subtracting, the first number is larger and the second number is comparatively smaller, then my answer is always going to be positive. To represent positive, I am writing greater than 0, alright? And what if you are doing, taking a number that is larger initially? For example, if I am talking about, say, 1 minus 2, what now? Now 1 minus 2, what is the difference between 1 and 2? That's obviously 1. But since I'm subtracting a larger number from a smaller number, larger number is 2, smaller number is 1. So my answer will be negative this time, alright? And negative, when we are doing negative into negative, it is the same as positive, but we actually attach the sign of negative, alright? For example, if I ask you to add 5 and 8, so your answer is going to be 13, alright? But what if I'm asking you minus 5 minus 8? Now the rule says that you have to add them. Negative and negative are added when you have the same size. So 5 and 8 will be added as 13 only. But since you have a negative sign, so you're going to write minus 13. Now how to remember these rules? You can simply think it of as whichever is whatever is the sign with the larger number, that sign is going to be put. For example, if I'm talking about minus 8 plus 5. Now clearly 8 is a larger number. So I have to simply see the difference between 8 and 5, that is 3. And since 8 is my larger number and my larger number has a negative sign, so I'm going to put a minus over here. Other example, say I'm calculating minus 20 minus 10. Now simply I'm going to add them, that is 20 plus 10, that is 30. And the sign with the larger number is negative, so that means this becomes minus 30. What if I'm calculating 5 minus 6? Now the difference between 5 and 6 is 1. And since there is a negative sign with a larger number, that is 6, then minus 1. What if I'm calculating 6 minus 5? Obviously the difference is 1 and 6 is my positive number, right? So this gives me 1. Now that were the rules for addition and subtraction. Let me tell you about the rules of multiplying or dividing two positive numbers or two negative numbers, or one positive, one negative. Now in our concept, when the signs were same, that is both positive or both negative, we were actually adding. Similarly in multiplication, when my signs are same, when both of them are positive or both of them are negative, then my answer is always going to be positive when the signs of two numbers are same. For example, 2 into 2 is 4. Minus 2 into minus 2 is also 4, right? Now 4 divided by 2 is 2. But minus 4 divided by minus 2 is also 2. Why? Because whenever my signs are same, then I'm saying that my answer is always going to be positive. Be it the sign is positive or be it that both of them are negative. Similarly, but now what if I'm taking one positive, one negative? Then in that case, my answer is always going to be negative. For example, if I'm doing 4 into minus 2, so that will give me minus 8. Or if I'm doing 2 into minus 4, again 2 into 4 is 8 and I have one negative sign, that means minus 8. Similar is the rule for division. 8 divided by minus 4 is minus 2. Also minus 8 divided by 4 is 2. Now when I'm writing it in fractional form, you can also say it that minus 8 upon 4 is actually same as 8 upon minus 4. So I don't really have to calculate them differently. So to multiply or divide directed numbers, we just have to see the sign accordingly. Alright, and we have to use these rules which are given over here. Examples. I've already given you the examples. I've already added, subtracted, multiplied, divide, etc. And these are the questions that you can attempt for yourself. Alright, I expect you to practice these questions as many as you can. Now if I have to write down 4 multiplications that give answer minus 12. So let us see. I clearly know that 3 into 4 is 12. But since I want a negative sign over here, so I can either do minus 3 into 4 or I can also do minus 4 into 3. That's also going to give me the answer as minus 12. I have 6 into 2 is 12. So minus 6 into 2 can give me minus 12, or minus 2 into 6 can give me the answer as minus 12. Similarly, I can calculate the answer for any given number. Now this is your homework question. Just pause the video and try to do this question on your own. And if you have any doubts, you can write to us anytime and we are going to hold a special doubt session for you. And there are the last topic that I'm going to explain you for today. That's the hierarchy of operations, about BIDMAS that you have already studied in year 5 or year 6, I suppose. So whenever we are adding, subtracting or multiplying two terms, then we have to follow a particular rule. Alright, first we have to look at the brackets, then we have to look at the order in which they are occurring, and then I have to see the division sign, then multiplication sign. So that's BIDMAS. For example, over here I have, now first of all, let me just write BODMAS or BIDMAS. It's one and the same thing actually. So first my word is brackets. So I'm going to solve my brackets. So 8 minus 3 square is 9. So what is 8 minus 9? That's minus 1. The rest of it as it is, into 9 divided by minus 1 plus 4 is 4 minus 1 is 3, so positive 3. So divided by 3. Now what do? Do I multiply first or do I divide first? Now over here I have division, D initially. So I'm first going to divide it. So this is actually equal to minus 1 into 9 divided by 3. 9 divided by 3 is 3 and my answer comes out to be minus 3. Now if I'm not following the standard rule, my answer could be, I could have answered it like minus 1 into 9, that's 9, and then I would have done minus 9 divided by 3. Okay, over here I'm getting my answer to be same, but the answer is actually not always same. I may get different answers. So to avoid such kinds of confusion, there is a rule that we follow. Alright? And thanks for watching us. We are done with the topic for today. I hope you enjoyed this concept, and now you have to practice more and more questions. You can visit our website, download the notes from there, and you can have a look at the practice sheets that have been given, and you have to practice more and more questions. Maths is fun only when you practice more and more questions. Till then, thank you. See you in the next topic.